so we're going to go ahead and finish off 8.2 today. Let's go ahead and jump right into example number 5. Example number 5 says integrating with respect to y. So we're going to go ahead and learn something new. In other words, we're going to go ahead and do the same thing that we did before, the same question that we had before, where this was y is equal to x minus 2. Then we had y is equal to root x over here. And we found that this guy was 2. We found this guy was 4. And so this is example number 5. Instead of... So when we did example number 4, we found that when we did the dx, we had to go that dx was different in this region versus this region. In other words, in this region, you were bounded by this guy and x equals 0. In this region, you were bounded by this function, root x, and this guy here, x minus 2. So we had to split it into two different parts. So if we did integration with respect to y, we would not have to do that. Okay, so let's go ahead and kind of look at that. So if I have a dy here, so this would be delta y now, okay? And if I look at it from a y standpoint, this guy here, so I'm going to subtract from this guy, subtract that guy, okay? So this here is now this guy. So you're going to go ahead and put them in functions of y as such. So this point would be that, and then you have another point over here, okay? So this guy here, you have to put it into y. So put it into y, what do I get? This is going to be x is equal to y squared, right? This guy over here is going to be x is equal to y plus 2. Okay. So this guy is the top function. This guy is the bottom function. In other words, this has a greater x value than this guy at the same y. Okay? Right? So the most confusing part about this thing is to be able to reorient yourself and look at that y. Now we're looking at delta y or dy. So we're looking at the larger x. You want to subtract from the larger x to the smaller x. Okay? All right. So this function now becomes this entire thing so I'm going to go from where? I'm going to go dy, right? So dy, but this is the top function, like I said, and this is the bottom function right here. So the top function is this guy, y plus 2. The bottom function is that guy, so I'm going to subtract that. It's going to be dy, except for y is going to go from where to where? Y is from 0 up to 2. So I'm going to go from 0 to 2 and like that. So as you can see, it is simpler compared to the one before because what? Because I don't have to divide it out into two different spaces, right? Okay. So there were two different regions. So let's go ahead and see if we can do this. We get what? 1/2 y squared, 2y minus 1/3 y cubed, 0 to 2. So I put 2 in there. I get 4 divided by 2 is 2. I get 4 minus 8 over 3. So I get 6 minus 8 over 3, which is what? 18 over 3 minus 8 over 3, which is 10 over 3. Same thing, but you can see it is much cleaner, much easier, simpler, one step, okay? Compared to what we did in example number 4, okay? So example number 5, we do it using dy, okay? Again, it is the reorientation. You have to be able to see that in our traditional sense, we have x and y. This is the first quadrant, right? It's the same thing, okay? y is going to be positive here. Y goes positive as it goes over here, and x goes positive as it goes over here. But now you're looking at it from a dy standpoint. Okay. All right, so let's go to example number 6 and see if we can use this concept. Okay, example number 6. We have example number 6. Find the area in the region enclosed by the graphs y is equal to x cubed and x equal to y squared minus 2. So if I do that, I'm going to get what? So I have x is equal to y minus 2, and I have y is equal to x cubed. X cubed, we know how it works. It's going to look like that. Okay. Y is the x bar. So over here, if I have y is equal to 0, which is over here, y is equal to 0 when x is equal to negative 2. You have negative 2 here. It opens up like that, right? So I'm looking at this part right here, okay? Again, if we look at it, if I want to go from d and a dx standpoint, dx-wise, this guy here, this region, is going to be different than this region because I am in this region from here to here, I am surrounded by this function and this function, but over here I'm surrounded by this function and a totally different function over here. So I would have to put it in 2 different places, okay, 2 different regions. So, but if I do dy, what do I have? I have this guy is always going to be larger than this guy, right? Because we're looking at a dy right here, right? Like that. Okay, if you look at it that way, this is going to be a little larger as compared to that, right? So this guy here, this function here, is always going to be larger or dominates this function. Well, first of all, we need to find these 2 points, right? We need to find this point and this point here, right? So how would I do that? I would have to set these equal to each other. And what do I have here? If I put this in here, it looks like I'm going to have x is equal to x to the 6th minus 2. Okay, there's no easy solution here. So we're going to go ahead and just look at our calculator and trace it. And if I do that, what do I get? I get negative 1 and 1.793. So I get negative 1 and 1.793. Okay? All right? And these are the y values, right? These are the y values, because that's what we're trying to find, right? So if we go there, so we're going to go from where to where? I'm going to go from negative 1 to 1.793, right? And I'm going to have this guy is larger, so this guy here, but I have to express this in y, so x is going to be equal to that, right? So I'm going to have cube root y minus this guy. So it's going to be minus that guy dy, right? So basically it looks like I'm going to just go ahead and mint this anyway. So if I mint it, right, and I'm going to get 4.21. 4.21, right? I mint it not because this is hard to do. This is easy to do. It's just the values that you're going to put in are this, which means you have to use your calculator anyway, so I would just go ahead and do it and mint it. Okay, last but not least, example number 7. Example number 7, we're going to give you we're going to go back to our original question and give you a little trick to show you how to calculate it. If you go to the original question, our original question was, we had y is equal to root x, and then we had is equal to x minus 2, 2, 4, and we're trying to find this guy, okay? Well, the way we're going to find this guy is we're going to go ahead and, since this guy is nothing more than a isosceles right triangle, right? Because this is 2, this is 2, right? So the area of this guy here is what? This is going to be 1/2 base times height, right? Which is 2. So in other words, I can take this guy and just find this guy and subtract 2 from that away, okay? So this guy is simple, so I want what? From 0 to 4, root x, right? Root x dx, right? So I'm going to subtract the 2 from that. So I'm going to get, what am I going to get? If I do this, I get what? 3 over 2 x, 3 over 2, 0 to 4. Okay, all right. I put the 4 in, what do I get? I get 2, 3, 4, that's the 1/2 there, cubed, so that's going to be what? 16 minus, because this is going to be 8 times 2 is going to be that, right? So my area is going to be 16 over 3 minus 2. I have to subtract the triangle here. So that's going to be 16 minus 10 over that. Not 10. I meant 6. Same exact answer, right? Okay. And we're done with 8.2.